today we're going to look at just a couple of tips and tricks about how to process a linked list, not of nodes this time, but of arrays. Okay, we're going to use arrays to implement a linked list. Today we're going to look at how to initialize an empty, I'm going to call it an empty free list, like the one we've got here. This list has 5 nodes, or 5 elements, and each element has an array associated with it, but there's no data. You might think of these as placeholders. And we can see that the free pointer is at index 0, and the end of the list finishes as usual with a -1. That's the end of the free list. We don't actually have any linked list data in this yet. So that's going to be the second part of this, is we're going to look at how to insert a new element or node or array, whatever term you want to use, at the end of the list. So we're going to be updating the free pointer as we go through this process. So first of all, let's look at how to initialize an empty free list. Let's use this as an example. Of course, we could do this. Okay, you know what I'm doing. I'm just going to make 5 arrays within the array and populate those arrays with this data. So we start with none1, then we go to none2. And this is fine, it's legitimate. We only have 5 elements to create within our 2-dimensional array, but we should really know how to do this programmatically. So let's have a look at that. How can we do this programmatically? Well, let's just break this down a little bit. In my array, my empty array, what if I type this? What will this do? Well, we can guess that 5 times it's going to generate a 0 and just create 5 elements, all of which are 0. To see if that's what is happening, let's just print the list. And that's exactly what's happening. Could we replace that 0 with an array which looks like this? So we can assume that 5 times it's going to generate an array with this data in it. So we should end up with a 2-dimensional array. Yes, that's what we've got. A 2-dimensional array with 1, 2, 3, 4, 5 rows. Why don't we replace that 0 with an I? Let's use the control variable to help us populate the 2-dimensional array. Okay, actually we're getting quite close to this design now. This is offset by 1. It should start at 1 and not 0. So let's just add 1 to that. Boom! The only thing that's missing is if this is our free list being initialized, the last element needs to have a next pointer of -1. So we are actually going to do that as a hard code exercise. List 4 will be assigned none -1. So the final element in the list will have this array. So let's run that. And that's what we've got. We've just initialized a kind of an empty list. Just an empty list. It's a free list. Everything's free. And the free pointer starts at 0. Okay? So let's just make a note of that as well. As we get started, let's just initialize a few of our variables. Free p equals 0. Okay. Now let's look at how to insert a new element at the end of the list. So this is going to require a new node. I'm just going to call it n, and let's also give it the latest value of the free pointer, because that will need to be updated as we go through the process. Now let's just look at some logic here. And let's also just make sure we reference our global list variable within this function. We can assume that if fp is -1, then the list is full. Okay. Free pointers at the moment is 0. Maybe we add something, goes to 1, free pointer goes to 2, goes to 3, goes to 4, and it hits -1. The list is full. Okay. Let's look at another piece of potential logic for this problem. Else if the free pointer is 0, we could suggest that the list is empty, and we need to insert our new node, n, just at element 0, at the root. We could just do it that way, right? Now remember, the root might not always be 0. Be careful about that. Your root node, for some reason, could be 2 or 4 or whatever. But at the moment, let's just consider this scenario, and we'll say that fp equals 0. To make this really clear, I could just say root. And let's keep it simple, guys, because we've got quite a lot to cover. If fp is 0, we could just say, listen, why don't we update fp to be the next value of fp? So fp will become list 0, 1. List 0, column 1, which is this value here. And then we can simply put the new node into position at index 0. So that's a bit of logic that probably might work. We can assume that if the list isn't full and this isn't true, that it means there's already something in the list. There's already been some processing. Insert at end. What I mean by that is maybe this function has been called a few times and a few things have changed. For example, let's just look at a new scenario. We called it, we added some data, and then we added some more data, and then we added some more data. And this became the end of the list. We now have a list. This is a list. And this is the start of the free list. The free list has got smaller because the list is getting bigger. Okay? So let's imagine this is the current scenario to help us consider this third condition within our logic for inserting. So, if we want to insert this node into here, where the free pointer is, this is where we're going to put it, we then need to link it to the list. So this value will become fp, right? That will become 3. So we'll go from 0 to 1, 1 to 2, 2 to 3, and then 3 to -1. Because we're inserting at the end, the new node should have a next value of -1. This will be the new end of the list. So we need to grab that index number, which is telling us the node where the end of the list currently exists. Hopefully you've seen this logic before. Let's have a look at how we do it. I'm going to set a search pointer to be, let's start at 0. I'm going to say while search pointer doesn't equal -1. We're just going to loop through. We're going to update search pointer. List search pointer, and the pointers exist in column 1 of each of these arrays. So when this loop finishes, search pointer will have a value of -1. Actually, we need to grab that too as well. So let's just set up another variable here. Current pointer equals search pointer. Now hopefully you've seen this logic before. If search pointer is 0, current pointer becomes 0 and search pointer becomes 1. Current pointer becomes 1 and search pointer becomes 2. Current pointer becomes 2 and search pointer becomes -1, and that's game over for the while loop. That's finished now. And the final value of current pointer is 2 and the final value of search pointer is -1. That's exactly what we need. Now that we've done that, we can just simply change this value to FP. Okay? Oh, I tell you what we haven't done yet. We haven't put the new node into place yet. So we need to do that. List FP will be assigned N. Okay, so this will go here. Oh no! I've just overwritten that 4. I don't want to do that because later I want to move FP to that value. That will be the new start of the free list. So we've overwritten it. Before we overwrite it, let's grab that 4. Next free equals list FP, list FP 1. That's column 1, isn't it? We need to store that or we're going to be in trouble. So store the next free, put the new node into the list at the free pointer index, search for the end of the current list, and now we can say, okay, list current pointer 1 will be assigned free pointer, because we haven't updated the free pointer yet. List current pointer 1 will be assigned the value of the free pointer, and then we update the free pointer. We just grabbed it, remember? I called it next free. Now, I'm going to make this a function. What I mean by that is I'm going to return, when everything's finished, when all of this logic is finished, I'm going to return whatever the value of FP is. Okay? Now, how can we test this code? I'm very quickly going to define a display data method, which manipulates the global list variable. And let's just do this very quickly. You know what I'm doing. Well, it doesn't equal -1. We're going to print the current data value, which exists in column 0. And we're going to update the search pointer. Okay, so that's display data. So let's have a go at this. What we're going to do is create a new node. Let's start with 13, -1. We're going to insert at the end, and we're going to store the returned value, which is the new free pointer. Insert at end. We're going to send it the new node and the first value of the free pointer, which is 0. So let's just start with 0. Then let's make another new node. Let's say 16. The data is 16. Again, the next pointer will be -1 because we're inserting at the end. And let's call that function again. And we'll send it the new node that we've just made. This is the 16 one. And instead of 0 this time, we're going to send it the value that was returned from the first call. That's the new free pointer. So let's do all of that, and finally, let's call the display data procedure, and hopefully it will show us 13 and 16. So let's run that and see if it works. It works!